all of us have knowledge in something or the other, and then it'll be a good thing to share our knowledge with each other, benefit ourselves and benefit the other person too. And also a little bit later, I'm going to pass around a little sheet which would have a name, an email address column, and your interest. Like your interest, basically, we do invite any and everybody who has some specific knowledge in a certain field, if they'd like to come and share it with others on a presentation, or maybe we can even have a bunch of people, like say talk for 30 minutes, 20 minutes, we don't know. We are also new to this, but we are always open to ideas. And so if you guys want to share your knowledge with everybody else, that's also welcome. So I'd give you this sheet around. Just put your name, your email address, make sure it's legible. Sometimes the names, if they're not legible, we won't be able to contact you. And then your interest, if you would like to participate or present in a future time. And that'll be great. Also, this email address, we will soon, we don't know exactly when, but we will put all the participants from this time and the last 2 meetings that we've had in a blog or something, and so that people can interact with each other more to gain more knowledge. That's the motive, but we'll get started now. Please.
Hi everyone. Hi everyone, this is Vinay. I have been in IT industry in software testing for 5 years, and I work on automation, Selenium, and I learned Informatica, and I want to start my career in data warehousing also. So this would be good for me, and I thank Suresh for this wonderful presentation and lecture. Thank you.
Hi, I'm Bala. I've been in the software industry for 20 years, but mostly from a mechanical engineering and design software. And I think some of these techniques are pretty broad and generic to apply in design problems. So that's why I'm here. Thank you.
Hello everyone, this is Murli Pasmarthi. I'm in software industry for about more than 8 years. I've been in the MDM space. I'm a tool guy. I do some visual analytics, and most of the time it's all MDM. Thank you.
Hi, I'm Venkatesh. I'm also in IT, but specific to the financial services industry. And yes, I'm the Venkatesh Suresh referred to earlier.
Hi, I'm Aditi. I'm in IT industry for about 8 years. I work on developing reports based on Cognos, and I just enjoyed this presentation. Thank you so much.
Hi, I'm Anita. I'm basically a Java J2E person. I've been in this industry for about 14 years now. I work for Scholastic, developing student software, e-learning software, and I'm also working on analytics on student learning and all that stuff right now. I'm very much interested in data science and looking to make a career in that. So this has been a very useful presentation, and the last one that Samirji gave at Billerica also was wonderful. I'm looking forward to more and learning from all of you.
Hi, my name is Venkata Visapragada. Mainly working on the old mainframe systems, on the telecom. Just want to diverse my interest in other fields, so I'm here. Thank you.
Hello, my name is Erwin Taylor. I'm a software engineer. I've been in the industry for about 30 years. I'm into tools for developing scalable applications. So if you have a application that you want to grow dynamically while it's still running, those are the kind of tools I'm working on.
My name is Venkat Kalathur. So same last name is Suresh Kalathur. I'm a SQL Server developer. Just interested in data mining and machine learning. So that's all.
Hi, my name is Raj. I'm Raj Ambati. I work for TJX, and I'm in program delivery. So there is something called technical architecture, which is a marriage of both software and hardware. So I pretty much deal with everything at TJX, starting with infrastructure to delivery.
Hi, I'm Pashupati. I've been in the IT industry for about 18 years. And like somebody mentioned, my primarily technical skills are in mainframes, but the last few years I've been working with migrating mainframe applications to other technologies. So this is all interesting, so I want to understand what data mining is. That's why I'm here. Thank you.
My name is Ashwin. I'm a senior in high school and just looking for some sort of career path, and I think data mining is for me.
Hi, my name is Girish, and I'm a software engineer working mainly in the Java financial applications. I'm interested in big data. Unfortunately, I missed the presentation by Anil, but I thought I could pick up something over here and help relate to it. Thank you.
Hi, my name is Sitaraman and I'm in the IT industry for more than 25 years. Basically, I'm the account management side and trying to get into the technical side, and I try to know more about the products. That's about the background.
Hi, my name is Shubha. I'm on the IT consulting side, so I go to client sides to implement currently in Pega software. My interest in this has been we are implementing call center applications for a client where we are, which is like an acquisition, mergers and acquisition. So merge and building a front end for about 10 legacy systems. So data mining has been one of the biggest challenges because of the diverse applications that we are trying to integrate. Hence my interest in this.
Thank you. My name is Karthik. I've been part of IT industry for the last 10 years. I work in SAP technology, mainly in professional services and techno-functional. That's about the story. This data mining is almost, I'm able to correlate a lot of things that I do in my day-to-day life. Thanks for this.
Hi, I am Eli. I have been in IT industry for 8+ years. I'm working on Java, JD and Oracle Peoples. Right now I'm working on data governance, RSA, Oxca and IBM Tivoli Identity Manager, Identity Analytics products. Thanks Suresh, thanks for the presentation.
My name is Padma. I'm in the database administration for more than 17 years now. Last 2 years, been trying to get more into BI and big data. That's where I'm getting my hands dirty with a lot of different things. So I thought I get into get some knowledge from more experienced people. So thank you so much for your.
Hi, I'm Swati, and basically I'm not from this field. I'm from mechanical engineering field, and I'm trying to change into analyst field. So I'm just exploring things and learning more about it.
Yeah, thank you, Mr. Kalathur. This is very helpful, and nice to meet all of you. My name is Vishal. I work down the street for Conservation Services Group, which is in the green energy field. Basically, the company makes software that makes recommendations on improved energy appliances that can be deployed on customer sites. So this is one of the areas where a company can really use improved mining techniques and better intelligence engines and recommendations process that it utilizes currently. So once again, thank you, Mr. Kalathur, and I'll be looking forward to meeting the rest of you in the future as well. Thank you.
Hi, my name is Vishweshwar. I'm in IT industry for 15-16 years, and I'm working on integration technology, integration platform for last 14-15 years. Generally work on enterprise integration and B2B integrations.
Hi, my name is Tribhuvan Arapalli. Thanks for the presentation. Actually, today I'm here to know more about how the data mining works really. So if you see day-to-day life, everyone talk about predict what is going to happen. So even I have the same challenge, how the places I work, they ask for prediction every day. So I would like to know the tools that really help. And there's a lot of data growing every day, day by day. So it's really challenging to really predict the correct thing. So I'd like to know the open tools that are here. So that's the reason I'm here. And by the way, I'm in IT for a couple of years now. I think from 2000, 2001, in IT. So thanks for giving me time.
Good afternoon, everybody. It's been a pleasure meeting all of you. My name is Samir Singhal.
I've been working for about 25 years, and almost all the time has been in business intelligence or analytics or big data kind of areas. And all of these technologies are fusing these days, and data mining is a natural fit. Suresh, I'd like to thank you for the presentation today. And as far as work is concerned, I work for Oracle, and I run the North American consulting practice for analytics for Oracle.
Hello everyone, my name is Baldeep Gandhi and I have just recently graduated in project management. And understanding the market for job and everything, as technology is driving the market actually, so getting hands on technology and trying to explore more fields and get good career. So that's why I'm here, and thank you everyone.
Hi, my name is Shiv Shankar. I'm in the IT industry. I've been exposed to a lot of applications and databases. So I just need to know what the industry is going in what direction.
Hi everyone, I'm Akila Narayan and I'm just writing an article about this presentation. Let me just say that I'm very technologically challenged. I don't understand this stuff, but Suresh uncle is such a good teacher. Something is getting through, so thank you.
Thank you, everybody. It is really, I'm really overwhelmed. I'm very happy to see somebody who's just in probably school, high school?
Yeah, junior.
Junior? Okay, school, and then who's just graduated and who has probably 30-40 years of experience. It is really nice that we could get a nice bunch of people here together. And I'm going to hand over the mic again to Dr. Suresh, and he is giving us a lovely presentation. Let's just enjoy. Thanks.
Thank you very much. Alright, so before I go to the tools, right, so if I don't show this, I'll forget. So if you are into the, some of you are doing the visual analytics. Alright, so this is recently came, 40 maps and charts that explain sports in America. So this one, this link I didn't keep in the presentation, but I'll share it with you later. And obviously, most of you, I assume, are waiting for tomorrow's game. And then, if you want to see how to visually analyze, this is a good one. America's weird taste in sports. Obviously, the ones we like, nobody else likes or nobody else plays. So you see the various, here there are the football and all this cricket and so on. Obviously, see the red cricket one where it is popular. So whatever it is, so it's visually showing the data, and then where the professional play. This is for our American sports, for each of the states where these pros are coming from. Alright, so and then so various sports and how they are working. Popular sport, 1940 through the 2010s. Football was now at the peak, right, and so on. So there are various ways of visualizing the data and interacting with the data. So that's one. There are 40 such charts of how you describe the various ones. The other interesting one, if you're into the games and then if you want to apply the analytics to the game, these are just analytics, taking the data and visually describing what the data is about. So this is a nice one. It's not popular anymore, but whatever it is, when it's in peak, there are several users who are using this, the massive multiplayer online games where all your kids are playing every day. Right, so this is one of those. And then basically during the last 14 months of that game's demise, so they captured all the data and then analyzed the data. And here is basically they came up with 4 clusters of the people. So these are the hardcore players. And then they're going from the hardcore to the casual. So those are the colors that were being used in these charts. And this is the Sankey diagram. And then you can see here, they're starting with this one, among this hardcore, and then out of this hardcore, when they go to the next month, at the bottom for each month, from that November 2011 to December 2012, and out of these people, how many of them from hardcore became, some of them still, the first one is the hardcore, but some of them actually went from hardcore to the moderate one, some of them moved to the casual one, and so on. So it's basically interactively looking at each of the groups and see how the people have migrated from one group to the other. So it's a very, if you're doing a web development, this is basically done in D3.js, JavaScript library for visualization. Well, most of these are the client-side ones. Right? So there is, the visualization is another one, so probably at some point in the future. So that's one topic that we could target and see how to present the data and how to interact with the data. So that's a very interesting. So back to our tools. So there are two ones I wanted to do with. So we'll go just a little bit beyond our time, but so the first one is a open source one for data mining. So it's called Vika. Go straight into this one. So it's basically developed in New Zealand, and that's the University of Waikato Environment for Knowledge Analysis. So any machine learning technique that you come across, you will have an implementation of that within this one. So it is an open source, concentrating on the open source. It's under the GNU, General Public License. So you can actually take the source and then you can modify it and then distribute it. Or you can just use it yourself, take a look at the source and basically see how the various techniques, purely written in Java. And then when we do the demo, we'll take a look at the user interface for those ones. So briefly, I'll show you here in the slides. When you go to take a look at the slides, you can run the application and then you can follow the application yourself. I'll just describe them in the slides. So we'll just concentrate on the first one. They call the Explorer. So this is for exploring the various data mining techniques on the data. And even though Vika is running on the desktop, you can apply, it's just a Java program, so you can apply it on the big data as well. So if you have configured the Hadoop and then you did the map reduce on those, it's also a Java program that you can apply the technique on each one of those. It's just like any algorithm, you can apply it and then do the reduction to get the results back. So it start with the regular data, and eventually when you go to the big data, you can work with these applications as well. And then they have the other components as well within that. So the typical things that we do, so we start with pre-processing of the data. First we'll get the data, pre-process the data, and then depending upon what you're interested, classification, clustering, association rules, and also talking about which attributes are the important ones. So these are the common ones that they actually represent. And also a little bit of visualization, they're not that fancy, but they do provide. So when you start the application, you will see something like this, all those tabs that are there on the top. And you have the source code, so if you want to add something or you want to add a different algorithm, you can easily go and modify the source code and add various stuff to this one. Alright, so it looks like this, and then once, just briefly give you a demo soon. So pre-processing the data. So most of the data that you get, typically if it's from the web that you're downloading, most of the time they will give it to you in the CSV format. So if you go to the census data, so it will be like 200, it will not be in a single file, so it will have multiple files. Each file could be about 200 megabytes in size, and it's just a CSV formatted file. So you can just import it in the CSV. For the Vika, they use this ARFF attribute relation file format. So it's, the data itself is in the CSV, but before that there is some pre-header information where they describe all the various attributes and the type of each of the attribute that is important for us when you're doing the data mining, and other types of data as well. So you can open it using a file, or if it's on the network, you can specify the URL. It will import the data. You can also get the data from your SQL. It just uses the JDBC driver. For those of you who did the Java stuff, so you get the JDBC driver for that particular database, specify the connection string, we can connect to it and get the data. Or it also has the capability to generate the random data. It doesn't have to be any, just random data for the attributes you have specified, and then you can learn what those techniques are about. And what do you do with the pre-processing? So if the data is ready to go, then we are all set. We can just go to the next data mining technique that we want to analyze. But most of the time, there would be some kind of pre-processing. So you need, assuming that the data is clean, so no noise in the data, all of that have been taken care of. And there are techniques for eliminating the noise as well if there is noise in the data. Sometimes you'll have the missing values for the attributes. How do you take care of the missing values? Those are also there as part of the pre-processing. So assuming that all is done, the most of the important one that we are interested in is some of the techniques, they work with numerical data, some of them they work with nominal data. Right? So some of them want you to be in the yes/no format or the true/false format. Some of them would take the actual values associated with those. So if they are taking the numeric ones, then if you have the data in the numeric format, again we are ready. Otherwise, we need to pre-process it and convert the data into the discrete format. Good example is the age. So you have the data in the form of numeric format, but you want it in the discrete format. So what do? You specify the various bins, maybe 0 to say 20, one group, 20 to 35 is one group, and so on. You can divide, you can give your own labels for those groups. Similarly for the income. Below 10,000, 10,000 to 50,000 and so on. you can specify what those groups are and then transform the data into those, convert the numeric data into this nominal form. Alright, so all those, once the pre-processing is done, then we can work with those. And then you can take the entire data, do the analysis, or you can take the subset of the data and do the analysis. So those options are provided for you. And then the various attributes that you get with the data. So if you go to the census data and you look at all the attributes, most of them may not be relevant for you. So what are the attributes that you are going to select? So you can eliminate them just by picking, okay, I don't need these attributes, or you can analyze the importance of those attributes and then improve only those attributes. So in all the data mining techniques, the more the number of attributes, the more complex the data mining process is going to be. The more the size of the data, the more time it's going to take. Right? So, but the time is, it's all relative here when we're talking about the time. So we're talking about from milliseconds to seconds in that particular range. It's all basically how important it is for you to work with that one. Right, so for the demo, right, so this is the data set I'm going to pick. This is a classic data set when they started the data mining techniques. So in the early 1900s. So there is 3 types of species of those flowers, and those are the names for those: Sedosa, versicolor, virginica. And then they picked 50 samples of each of these types and measured 4 properties associated with these. So this is a classic classification one. We know what type of flower it is, and then we have a measure of the attributes associated with these, and that is the data. We want to train the model, and then we can verify against that model. Right, so, and then the 4 numeric attributes that they collected, it's between the petals length and the width, and then the sepal length and the width, separating those ones. And then we have the classification label, so what type of flower it is. So 5 attributes describing the data, 50 samples from each. So there are 150 rows in the data set, and then we will use that and then see how the output is going to be for each one of these. Alright, so the data is in the bottom here. So there are 150 such rows corresponding to those. The first 4 ones are those, the length and the width of the sepals and then the petals. And then those are reals, whatever the numeric values that we have. So this is where the types of the attributes comes into picture. So the last one, we'll just call it a class attribute. That is the group that it belongs. It's just a name for the attribute. So we'll just call it the species or the class, whatever you want to call it. And these are the 3 different values that are associated with those. If we say yes, no, we can just say yes, no, true, false. Those are the options. If it is a discrete one, we will explicitly list those discrete ones. If it is a numeric one, we'll just leave those as numeric. Right, so this is for the numeric data ones. And then here, once you load the data, and then immediately in the first tab itself, you'll have the list of attributes. And then you can visually see if it's a numeric one, so what is the range for each one. And you have all this, the mean and the standard deviation, maximum and the minimum. And then you can basically see from the minimum to the maximum. And then these 3 colors that you're seeing are for the 3 classes that we have. And then those are the 3 classes, 15 instances of each. And for each of the attributes, how each one of these. So immediately you'll have an idea here. There is a visualize all. So we can now look all the attributes and how they behave in each one of these. Alright, so there's, right, so you don't have, this is like you start the tool, load the data, and you're ready to go. Compared to the other, the big ones, where you have to first import the data and then work with, or keep it in the structure, and then write the queries, build the models, and so on. So for learning, this is one of the easiest ones to look at all the data mining techniques. And then you can go to the other commercial ones and see how they work. So there's a lot of learning curve when you go to most of the commercial tools that we work with. Alright, so once you have the data, so we have starting with the classification. So we know what the class is, so because we need that information to train the model, and then we'll test the model to see whether it is correct or not. Alright, so for the decision, for the classification, the tree model that we have seen, so that is building a model and then testing whether a new data falls into one of those classes. If you don't want to build a model and then predict whether a new data belongs to one of the classes, and for those of you who did the statistics, the Bayes theorem that they use in the statistics, so that is the one that they use. Alright, so again, all the things that are there from the statistics, now we use them all over again when you're doing the data mining techniques. If you want to build a regression model and predict one of the numeric attributes in terms of the other ones, then we can do the regression as well. And there are various other ones. Any technique that is there is implemented. Alright, so and then here, when you load the data and when you pick the classify, and then you're ready to do the classification. So this is the test options that you are seeing. So using the training set, so whatever is the model that is built, So you're basically using the entire data to build the model and also verifying the entire data that you have used to check how many of them have been classified correctly or not. So you're using the model that you built on the data to see how many of them have been correctly classified or not. So in the simple example I showed you, or in that IRS example, all of them have been correctly classified, but you're not going to get a model most of the time. There will be errors associated with those. Yeah.
Yeah, so the attributes, how do you know which attributes to pick?
So this is when I come to the selecting attributes, so we'll talk about that one, which attributes to pick. For now, we'll see basically how the model looks like, and then we'll talk briefly about how the attributes were picked in coming up with the model. So when you did the classification, first step is basically selecting which technique you are going to use for building the decision tree, and the J48 that you are seeing. Right? So when you are writing a program, right? So when you give the names for the variables, you give the name X or you give a meaningful name for the variable. It all depends upon the guy who is developing that algorithm. He gave a J48 as the name for the algorithm. So you just go J48. So there is no meaning behind that J48. That is the name that the person gave. And that is the decision tree. So obviously here you have it in the text form. So the 5 attributes that we have used, so they are used for building them. And in the bottom you see the tree. If you had to describe the tree in the text form, so the petal width less than or equal to 0.6, then it's classified as the setosa. Just like we had the cheating or not at the root level, and then we had when they're not cheating, what happens. So that's basically a textual description of those. And if you want to actually see, I'll come back to this one. If you want to actually see the tree, there is an option here to look at the tree, but that is the decision tree. So the first attribute, the model pick, is the petal width. If you go take the same data and you use some other data mining tool, you'll get an entirely different tree. It all depends upon the technique that they used for building the attributes. And for selecting the attributes, there are information gain, entropy, and so on. There are various algorithms for picking the order for the attributes. So they will use those depending upon which one you selected. It will be used for picking those attributes. And then when you look at the importance of the attributes, so you will see the score associated with each. And either you leave all of the attributes in the data or you eliminate some of the attributes yourself. Right? So here when the petal width is less than or equal to 0.6, the 50 of them, all of them have been classified into that category. So you get a new flower, you measure the width of the petal, and then if it is less than 0.6, you immediately conclude that it is of that particular type. So it would be easy if all the trees were like that, but obviously not. So and then the rest of the samples. So we have 100 other samples we need to classify. And obviously for the others, we have the length greater than 0.6. So here at that point, we have the rest 100. And we need to pick another attribute here to classify those separately. So in this case, again, going with the petal width, 1.7 and 1.7, less than, greater than. And again, petal length. In this particular case, 46, there are 50 of each. So 46 have been classified as this Iris virginica. Out of the 46 that are falling in this, one of them has been misclassified. There is one which belongs to the other one, the setosa, which fall into this category. So there is an error associated with this. And similarly in the other branches. So if you see the round number 50 in that one, a slash, if you don't see anything else, there are no errors in that node. But if you see a slash and some other number next to it, so that means that some other classes which basically doesn't belong to that particular class, they are misclassified and they were classified within that. The model is not going to perfectly fit all the items. So that is the error that is associated with the model. And coming back to this previous slide, at the bottom there is a matrix called the confusion matrix. So that is the term that they use to describe how many of them have been correctly classified and how many of them have correct. Whenever you have to compare two things, so they use the confusion matrix. So we have 50 in each. So if you take a look at the rows, so the first one, the 50 of them, Iris setosa, they have been classified correctly. In the second row, we have 0, 49, 1. So ideally, the diagonal has to be 50, 50, 50. So that is basically what we are looking at. If it's not 50, that means some of them have been misclassified. And in the second one, the B is the versicolor. So out of the 50, 49 have been classified correctly. One of them has been misclassified. And our model is saying that one flower, which is a versicolor, is being classified as the virginica. That is the third species. And when you come to the last row, 48 have been classified correctly out of 50. 2 of them have been misclassified as the versicolor. So ideally you're looking at that and then basically seeing how accuracy it is. So in this case, 147 out of 150 have been classified correctly by the model, giving us a 98% accuracy. But if you take, that's why they picked that data set. But if you take normal data sets, so it's very unlikely that you'll get that high accuracy associated with those. If your accuracy is very low, that means that it's not the model that's going to describe the data. We need to pick some other data mining technique which will be used for describing the data. All right.
So in this case, how is it possible that you have 50 there and 1 here? Because you have only 50 samples to deal with.
50 each one, 50 of each type. So 150 are there. 50 Iris setosa, 50 versicolor, and 50 virginica.
50 of setosa, right?
Setosa have been classified correctly. So the first branch that is there. Among the other leaves that you are seeing, they are between virginica and versicolor. So here, if you go in this branch, 48 of them fell into this leaf, where one of them is from that means 47 are versicolor. One of them is the other one, virginica, which is classified as incorrect in that particular case. All right, so that's what the classification errors come into picture. The ones that are classified incorrectly, they are done there. And then the rest, so virginica here we have 46 of those. And then if you go along this branch, there are only 3 of them which fall into that particular category. Another classification technique is the neural network, and then again those are the inputs and these are the outputs. So based upon that, we'll train the neural network, and then it will again, the last confusion matrix, it's like again 148 out of 150 have been classified correctly. They're pretty much high accuracy ones, so either of these models are fairly accurate for describing the data. And then if you want to run the prediction here, so you pick one, what is your Y? In this case, I want to predict the petal length in terms of the other attributes. Again, it's up to you how many of these attributes you are going to pick. You can include all of them, and then you can actually compare the relation between each one of these. So we have several branches in the tree. So if you take a particular branch, so there are 3 branches that it has identified, and each of those 3 branches, depending upon the items that are falling into that particular branch, so you can describe the length in terms of the other attributes. All right, so there is a multiple regression when you have the relation. So you can take the numerical data and then you can do the regression to predict one against the other, or you can build the decision tree and then see how they fall. It all depends upon what type of model you are trying to describe that particular data. All right, so and then I'll show you in the slides first, and then you can follow that using the tool, and then just follow the same sequence of steps and then come to it. Yeah, go ahead.
I've heard of a technique called self-organizing map.
Yeah.
Is that covered?
No. Yeah, so it's one of there are various other techniques that are there as part of that data. Support vector machines is another one that's commonly used. So coming to the clustering, so grouping similar ones. One of the most commonly used one is the k-means. K is the number of clusters that you need to specify what that k is. And then basically how we come up with the clusters. So we take the mean for each of those clusters. Initially we say 3 clusters, we randomly put the data into 3 groups. And then we find out what is the centroid for each cluster. And then see if all the items that are there in the cluster actually belong to them or belong to the other clusters. We move the things around. And then you repeat this process until they all converge. And then variations of that, there are other variations of those. All right, so again here for the data that we have, so again, if you want to do the clusters on the data, if you ask it to pick the clusters, it will come up with entirely different. So, but we know that there are 3 types of data. So we can specify here when you're running this one, the number of clusters. The -1 is for the algorithm to actually come up with a number of clusters. We can specify we want to go with 3 clusters. And then we can see basically how the clusters actually are formed. If you don't specify the number of clusters you're going to get is 5. And then the data that we have is split into the 5 clusters. Right? And then the properties associated with each of the cluster, and then how many of them have been correctly classified or not. So there's 60 of them have been incorrectly classified out of the 150. If you go with the number of clusters as 3, so you have those 3 clusters, and then for each of the attributes, so what are the properties for each, what is the mean standard deviation for each one of these in each of the clusters, and then we can look at how many of them have been correctly classified or not. In this case, only 14 have been incorrectly classified, that they are some other, they actually, we know what the class is, but when it grouped into the cluster, we put them into a separate cluster. All right, so depending upon the data that we have, so we can look at the accuracy and then see what is the ideal one for this scenario. All right, and then if you want to do the visualization of these, all right, So here on the x-axis, so we have all the 150 samples are going from left to right, and each whatever is the symbol that you are seeing, that is each instance that we have. And then y, you pick one of this is only a two-dimensional plot. So on the y-axis, you pick the length of the sepals, say for example, and then you will see that the clusters, the color of the clusters is whatever the red, blue, and the green that it's using in the original visualization. So those are the colors that it uses. So the first one, the 50 of them that were classified correctly on the first site, so those are all there. There were no misclassifications within that. So when you come to these ones, these are the ones, 14 instances we mentioned that they were misclassified. All these are these ones. So you put them into this last group here when they actually belong to this classification. Right? Because the values associated with those, they are more close to the ones that are there in other group than this one. So that's where the misclassification actually occurs. And they provide you the capability to actually take a look at those. Right. And then coming to the association rules. So this is the rules, like if these and these hold, then what is going to happen. So for the association rules, so we need the symbolic data, not the numeric one. So we need to convert the numeric into symbolic. So for this one, we'll pick a different one, the weather data set. And then just briefly about 14 observations, say for example, what is the outlook today, what is the temperature, humidity, whether it's windy or not. The play is here for playing tennis. So are you going to go out and play tennis or not? So based upon these observations, so you record 14 such ones. And then you want to see basically the model that is associated. You want to predict, given a new day with some other values, so what are you going to do on that scenario? Alright, so the same thing, you can take the data and then you can actually, we'll just go with the association rules here. And then it will come up with the rules like this. So if the outlook is overcast, then you are going to play, in this case, 4 out of those instances have that particular value. And with confidence of 1 is 100%. 100% confidence, you can say, if it's just overcast without any other attributes taking a look into it, you're going to go out and play in that scenario. If the humidity is normal and there is no wind, you're going to go and play. Alright, so if the outlook is sunny but the humidity is very high, you may not want to go and play. The play is no in that particular case. Outlook is rainy and the windy is false. Play is, as in this case, 3 cases where die-hard fans actually went out and played in that rain conditions as well. Alright, so you'll come up with the association rules like this, and then you can see under what scenarios it is applicable or not. Alright, so there are these are all the data sets that come with the Vika tool, or you can go and download your own data sets. This is a breast cancer data set, and right, so various attributes associated with the readings, so we have those. And basically this is reoccurrence of those. So the last class where there is a reoccurrence of that after all the treatments. So that is the data that they have recorded. And then here, if you take a look at the association rules, so the top rule is basically, so we get menopause greater than or equal to 40, malignancy of the tumor, radiation, then no recurrence of the event. So that's with 97% confidence, it comes up with the rule like that. So based upon the data that you have, you already have the class for that, whether it is yes or no, and then you want to describe the rules associated with it. And then depending upon a new data that you get, you look at which rules are applicable, and then you come up with those. Alright, so selection of the attributes. So what are the relevant attributes? There are various techniques again. So depending upon the algorithm that you are going to pick, you are going to get a different ones. So if it's a small number of attributes, then you can do exhaustive search of all possible combinations and then see which is the best one, but that's not practical. So there is a greedy algorithms for picking that, or just randomly go and pick the attributes. You want to do the ranking of those and see which ones are the ones which are important and how you are going to evaluate it. So there are various techniques for doing that as well. So in that the breast cancer data set, so the degree of malignancy, that is the one that came up very high. Whatever is the rank that you are seeing, they are sorted from increasing to decreasing order. And then you can see which of the attributes are the ones which are playing the role in that data set. So that is in the given data set. So, and then train the model when the new data actually comes into picture. Alright, so as far as the visualization in the Vika is concerned, very limited capabilities, but you can have an idea of what is happening. Alright, so all the 5 attributes that we have in the iris data set, and then you want to compare, say for example, whether there is a relationship between pairs of attributes. So you can plot the pairs between each of these, and then if you are, I don't have the correlation here, but if you take a look at the correlation, you would see whether in cases where it is So this one is actually cut out, but in cases you will see a positive correlation very close. In some cases, so say for example here, in some of them the correlation is very weak when you compare any pairs of attributes. Alright, so that's the typical correlation that we do. We can visualize and see those ones. Alright, so you can take these slides and then start week. I'll just briefly show you in the quick demo one of these techniques, and then I'll show you the harder one for doing the analytics part. Alright, so when you start the week, so you'll get the Explorer. Alright, and so unfortunately here the fonts are hard-coded in the Java code, and then I had to go and change the fonts actually for some of these ones. So in the data sets that we will pick the IDIS one. Alright, so those are the attributes that we have, and this is basically the information about each one of these. And then here, visualization of all of those attributes that we have, and for each class, how many of them belong. These are the numeric ones, so you'll see the overlapping in those ranges from the lowest to the highest. If they are discrete, then you'll just get the vertical bars corresponding to each one, how many of them belong to each of those classes. Alright, so and then and if you want to do the classification technique for this, so just showing you how many options are available for the classification. Alright, so there are various algorithms for these, and they are actually classified under various techniques. And then for the trees, we are interested in the decision tree, the J48 that we did. And then we'll just use the training set. So common ones are do a split. So they take a 2/3, 1/3. 2/3 of your data is selected for building the model. 1/3 of your data, you don't include it in the model, but you test it on the data itself. There is a cross-fold validation. So you specify how many folds. So it's like if I ask you to sit in the, you're already in the rows. So say suppose we have 10 rows, I take the first 9 rows and then build the model, use the 10th row to validate against it, and then I do the repetition. I pick the next 9 rows and the other row will become the test row. So I do it 10 times by specifying which 9 are the one I'm going to use, and then do it. So it will do all of those and specify how many times you want to do it, and then tell us whether that way it's going to come up with a better accurate model. Alright, so and then once you pick those, alright, so you'll see the matrix, how it is correctly classified and so on. And then there is visualization of the tree. Alright, and then there is an option to actually center it onto that page. Alright, so depending upon, if you have a bigger number of attributes, obviously the tree is going to be really huge. So once you build a tree, so there is a pruning part associated with it, just like how you prune the trees. So there are techniques to actually cut out branches of the tree to make. So there is a problem with the overfitting of the data. So you want to fit as much data as possible. That is fine with the existing data, but as soon as you go to the test data, they will start failing on the data. So sometimes you build the tree and then you prune the tree to the appropriate branches in this case. Right? So that's basically, it's very easy to use tool. And that is the classification, and you have the clustering, and then you can specify what type of clustering technique you want to use, and then start the clusters, and then here, this is the number of clusters that you are going to get, the properties associated with the cluster. In this case, it came up with 4 clusters automatically for the data. And then the options for each of the techniques that you can specify, the number of clusters, change it back to 3. And then run it again. Alright, so 3 of these. So usually, if you are, so why all this data is there? So once you cluster them, so taking a look at each of these clusters, so you can see which ones are the ones which are different. So if you take the petal length, say for example, the first cluster, the mean of that is in the 4.2 in the first cluster, 1.4 in the second cluster, 5.5 in the third cluster. In some cases, one of the attributes is very close, but there could be the other attributes which are actually distinguishing one from the other. So you look at the properties of those attributes and see how they are differing from one type of the data to the other type of data. So there are various other data sets you can pick and then run the technique and see those ones. Right, so that's briefly about the Vika, and then we have this visualization part. Right, and then you can select some of those data. Right, and look at the correlation associated between these attributes, and then you can see which ones are more closely correlated and so on. Right, so that's one for the data mine. If you are into the analytics part, So the easy one that you can learn is the R tool. All right, so briefly let me show you that R. So this one is actually written in C. So and then you can just get the distribution for your target platform, or you can build it yourself. Right. So it's based on a language called S, and then I don't know why they came up with the R, but I don't know if it has to do with the names of those two people who actually developed that one. So there is if you just download the R, you will get the command line version of this R. And there is an R Studio. It's just like a visual IDE for the R. It's more convenient for you to learn this R. Alright, so once you have those two techniques, statistical techniques, they classify linear, nonlinear regressions, all the classic statistical techniques that you have, all of them are there. Time series analysis, time series is another data mining technique. So basically, all your purchases that you're doing, obviously if you plot on the time scale, right, and then you want to do the analysis on those, there's the time series associated with those, classification, clustering, and so on, all of those. But typically when people use R, they start with the analytics part. They want to do see what is there in the data, visualize what is there in the data. For the data mining itself, the other tools are more applicable than this. You can still do those ones, but the results are not that meaningful. And you can use Vika with R, so all those combinations are there. And R comes as a basic one, and then there are a lot of packages that are available. And whenever you have a need for that, there's a repository of all the packages. You can a very one-step process to install a package, and then you can make use of those. The main advantage with R are the graphics that you actually do with R. So the R Studio looks like this, and you can type the R code here, or if you have a file, you can type it or run it, or you already have an existing file, you can load those ones. Right. And then any variables that you create, you can see what those are, all the help and the plots and so on. So you have another area for actually looking at those plots. All right. So briefly, the data types in your programming languages, you have the data types. So these are the data types that you actually use, and the data structures. So this is where they differ from the regular ones. So usually any data that you take is a vector. So it's basically of the same type. You can think of it as an array that you normally use. Sometimes you have an array of values, but they are of the distinct ones. So if you take a look at all the people who are playing the sports, there are only a few values that you have in that particular column. So instead of just taking them as separate values, they call them the factors, and that will help us in analyzing how the data actually works. A matrix, any two-dimensional data of the same type. List is basically a collection of the vectors. And then the data frame, a two-dimensional one, same size, but the columns could be of any type. The common ones that we use is the data frame. So you take any CSV file, you can easily convert it into a data frame and then do the analysis. All right, so when you're running this R, so all the code is there on the link, and then the data file is here. So this is basically, I just took the top 5 players in 2014. This is the Forbes richest players list. Not rich means by their sense. In that year, how much salary that they have earned, and how much they earn in their endorsements, and what sport they play. And if you take a look at those top 5, the first guy is the boxing guy. 2 of them are in soccer, 2 of them in basketball in this particular case, and the names are pretty familiar for all of you. Those are in millions of dollars in this case. All right, so that is the data that we have, and that is the variable athlete info that we are seeing. So and then you can examine each of the columns that we have. That is the notation that they use, the dollar, and then the name of the attribute. And then here you will see that when we have the discrete one, what are the various values? They call them the levels or the factors. And the numeric ones, we can get the information. So you can take a look at the summary for all the columns, or you can pick a particular column and then see what is happening with the data. For the numeric ones, you will have the 5-number summary here, including the quartiles, the first quartile, third quartile, the median one, minimum, and the max. For the discrete ones, it will tell us how many values are there for each one of these. So that's the basic data that you start. All the typical OLAP operations that you do, slicing, dicing, and so on, it's very trivial here to do that in R. So if you just want a particular set of columns and then create another variable for that one, so you're just picking the names of those attributes, or you can specify the column numbers, and that is the subset of the data that you're actually working with, and then do the analysis on that data. And if you want to slice the rows, you can specify what those rows are. or you can specify, say for example, all the players who are playing soccer, so that is our expression, it will only filter out those ones. Alright, so once you have those data, again we work with the subcubes out of the data. In this case, we're talking about the two-dimensional data. So rows and the columns, you can filter based upon that, or you can explicitly specify here based upon the expressions and then the names of the columns that you want to work with. Or there is a subset function which will work with. So if, this is like your pre-processing. So what type of data that you're dealing with from the original data. So once you select your data, so then you do it. If you have to do a new column in your data database, the total pay here as a sum of these, right? So you write the SQL code or a stored procedure and then run. In this case, it's trivial. So you specify a new column here for the pay. All the new ones are added at the end. It's basically a sum of those two columns. That's basically specifying the expression. And the data is modified here. We have the new column specifying those ones. Right, so the ones dealing with the data. The other thing is if you're interested in the statistics part, and if you want to learn more about the statistics, so they have this probability package. Alright, so we'll take some common examples. So you're playing a game with your friend, tossing the coin 3 times, see how many heads and tails you're going to get. There are 8 possibilities, and each one has a probability of 1 over 8. So that is your sample space. And then what is the probability of getting 2 heads, what is the probability of getting all the heads, and so on. All those questions could be answered with that data. I'll take another example for that one. All of you play the dice games. You have a pair of dice and then you roll. So you're rolling 2 dice, so there's 36 outcomes associated with them. And then all those 36, I just show you the top 3 and the last 3 here. Each one, the probability is 1 over 36 for each of those outcomes. So that is our data that we are dealing with. Alright, so what is the likelihood, which number has the maximum probability for you to get when you're rolling 2 pairs of dice? Alright, so obviously, yeah, 2 pairs of dice you're rolling, not 1.
Same probability.
No, so you're rolling 2 pairs of dice, right? So for getting a 3, so you have 1 and 2 or 2 and 1 between those. So you have 2 chances out of 36. Right? So among those possibilities that you're going to get, minimum is 2, maximum is 12. So which one has the highest probability for you to get? Right? So if you are good in these ones, you need to know the probabilities. Alright, so all these poker games and all is all based upon the numbers. Okay, so here we go. Alright, so you add a random variable that is the sum of those 2, and that's 2 to 12, and these are the probabilities associated with that. And if it's hard for you to figure it out which one has this one, we'll just single command here, plot, and here is basically the plot associated with that. So here 7 is here, that is the one which has the maximum probability for you. And you can enumerate all the possibilities for getting a 7. Alright, so we have 1 and 6, 2 and 5, 3 and 4, all those things. So that's the maximum that you're going to get. Right, so starting, that's basically showing you how we can use the plots. Concentrate on the plots here because you use it mainly for visual part when you're doing the R. So it's the iris data set that we have, so it's also one of the predefined data sets when you install the R. And then we can do summary of the data and look at the properties for each of the numeric attributes. The correlation, the previous one I just showed you the graph, but here is the correlation associated between any pairs of data, any pairs of the variables. And then the diagonal will be 1 because it is the same variable against the same variable. The negative ones are the negative correlation. The positive ones here, between the sepal length and then the petal length, you have 0.87. One is the perfect straight line in the middle. And then there is a 0.96 between the petal width and then the petal length. The other ones are a little bit lower correlation between those. And then the plot that we have seen, the correlation, if you take any of those pairs. So here is that one with the 0.9 correlation. And some of them you don't see any correlation. Those are the ones with the weaker ones. Some of them probably came up with a negative correlation corresponding to
Do you have
this.
any user interface in most of the visual analytic tools that
Yeah.
comes up?
So these are the ones where basically you are driving with the R code. Alright, so you just have this basic ID. You have the one that I showed you here, the 4 screens. So everything is, you don't have the menus and then to take the data, plot this, plot that, and so on.
I've seen tabloids.
Yeah, so that's right. So these are the open source ones we are talking about. And then you go to the commercial ones. Obviously the commercial ones, You go with the commercial ones.
Drag and drop.
More
basic
drag.
reporting we can
Yeah.
do.
More you have all the capabilities associated with those.
Suresh, can I take a moment on this point?
Yeah.
So what can also be done is that you can create the data set and export out of R in a CSV file.
Yeah.
And you can import into any commercial tool like
Yeah,
Tableau or Tableau. And that way you can bolt on.
Yeah. So yeah, but the capabilities, basically you have to go to the commercial ones. Okay. So these are basically meant for statistics people and then people who love. It all depends upon when you're doing the SQL stuff. Do you use the menus to generate your SQL or do you write the SQL code? For one group, we have one set of tools. For other group, we have the user interface different set of tools. So this is basically for you to do the coding part and then work with those. Alright. And then box plot of the data, so you can easily see here for each of the attributes. These are the outliers associated with those, the first quartile and then the third quartile. Any outliers are there in each of the attributes. You can just that's just the one line of code here. Box plot data, whatever the colors that you want. Otherwise, everything is black and white without the colors in this case. A histogram associated with the sepal length, and then you can see from 4 point something to some point something, that is the range, and then in each of the groups how many of those data actually fall. Mosaic plots, if you previously came across this, so you can pick a data set here. We'll pick the Titanic data set, another one that comes with the R. So this is basically who survived the Titanic. So here, among the data that we have, so obviously there are the males and the females. That is one attribute, whether they are child or adult, and the classification is whether they survived or not. And then whether the people that are there are in the first class, second class, third class, and then the crew. So that's basically the data that we have in the Titanic one. So just starting with the males and the females, the entire data set. So there are 1731 males and then the 470 females. So you can use a bar plot to show it, but in the mosaic plot, basically if you take a look at the males and the females, the widths are the ones which is telling the difference between this one. This is almost 4 times as wide as that one. So start with one dimension, and then now we'll introduce the second dimension here. So among the males and then the females, so how many of them have survived or not. So here, this is the males and this is the females. And then if you look at the cross tabulation between those two, you have the survived is no and S, and obviously here between the males and the males are more in number, but between the males, so how many of them survived, how many of them didn't survive, and then in the females, how many of them survived and how many of them didn't survive. So this, you can see the ratio between those two here. And then the width is basically with respect to the first dimension, the height with respect to the second dimension. So you can compare those. And then among all the passengers that were there in the 4 ones, so for the first class, so now taking a look at the data, how many survived in each of the classes. So here, the first class people here, you see that more of them have survived compared to the ones that have died. Compared to the second class people who are there, third class, they are in the bottom of the ship. The crew, obviously, unfortunately, they're the last ones to go. And you would see in each of the groups how many of them have survived, how many of them did. And then across also you would see the relative. So the first class passengers, similar number of second class passengers. Third class passengers were about thrice as those. And then the crew also more in number compared to those. There's only 2 dimensions. And then you introduce more dimensions. Again, it's shown as a 2-dimensional plot. And then you can see the differences between those. All right, and then if you want to use the data mining, so the decision tree that we have did, so the iris data set, so that is the species, that is the class column, against the dot is all the other ones. You can explicitly say the length, the petal length, plus, and so on, or specify all of them, or just pick one as your Y, and then all the rest, that is the dot there for all the rest of the attributes, that is the iris data set. And then here is the tree. So it has visualization of the tree, but it's not as pretty as the Vika one, but basically describing this. This is a completely different tree that it actually says. And then here, when the petal length is less than 2.45, the 50 of them were classified as the iris setosa, and the rest are coming in other categories. And then we can basically see how correctly it has predicted or not. So now in the columns, we have 50 of each one. So 49 here, 45 here. The 5 plus 1, 6 are misclassified in the other categories. Different model will give you different results associated with those. All right, so and then that is taking the entire data set. So in the Vika, so we had the option to pick, say for example, 60% of the data for training and 40%, say 30%, whatever it is. If you want to be more clear about how you are picking from each of the classes, so in this case, the first 50, the way the data is given, the first 50 is one class, the second 50 is in the second one, the last 50 is in the third class. And here, the sample is randomly, it picks 1 to 50, 30 out of those, the indexes corresponding to those. So picking 30 random samples from each one, that is easy to do here rather than doing in the visual ones. Alright, so once we have the data, we'll fit the model, and then we'll test it against the rest of the data. So testing it is basically this line of the code here. Whatever is the data that we have picked, minus of the data, that is the rest of the data. And then we will see basically among that. So there are 30 we picked for training, the rest of the 20 are there that we are testing. So in the columns, you will see basically here, the first one classified correctly. In this case, 16 correct, 14 incorrect, 19 correct, and then 1 incorrect in this case. Right, so the same thing here, visual ones versus this. And then recently somebody wrote an entire, it's a very big algorithm. So the algorithm, which is basically a half page in length, they just wrote everything in 2 lines of order. It's just the same expression. They concatenated it and came out. Nobody would understand that if people write the code like that. But it's very concise when you write the code in order and then come up with those. All right, so the clustering technique, the k-means, and then you're specifying 3 clusters and how many iterations you want to do on those. And then you can see here again, the clusters here is very poor compared to the last one, the way that it has classified that data. All right, and then you can do the visualization and see the red ones, those are the first ones. They are all, in all the models, they have been classified correctly. But as soon as you come to the other ones which are classified incorrectly, so this is the one where we had most of the misclassifications here. So we have 36 and 14. So the, coming back here, so the pluses are the ones which are correctly done, and then all the O's that you are seeing that is in this class, you see them as misclassified. And similarly here in the blues, the ones that are misclassified as pluses, they are classified as this particular category. All right, so you can take a look at the visualization part and then do that. So the website has all the details, all the tutorials associated with that. All right, and then briefly about that R. All right, so it, once it comes up, we'll take a look at this. All right, so those are the 4 areas that we have seen where the R comes into picture. And all the code that we have seen that is there, it's all the code that we have. Alright, so and then it's basically, you can do the entire source code, and obviously it's going to run through the entire code. Or you can just select, say for example, I'll just pick up to that point and then run that code. Alright, so it runs the code, gives you a summary information associated with the data. And then coming to that last one, or Titanic one, say for example, the mosaic plots. Alright, so it shows you the plots here in this case. There are other plots as well. There is this in the pie charts and then the stem and the leaf plots, all the classic ones that we see in the graphics, all of those are there in the R. Alright, so this is mainly meant for the visualization part, and any plot that you actually see is implemented in R. You can use that for this one. The open source tools, and then you go a Tableau or the click view and all of these. So they have the implementations of those.